Hey chemistry crew, Mr. Collier here. Today we're going to go through some basic notes on the concentrations of solutions on page 4 in your solutions packet. So the concentration is simply the amount of solute given per amount of solvent. So if I dissolve a lot of something, we would say it is concentrated. And if I don't dissolve very much of something, we would say it is dilute. So those are two terms that are fairly generic. They're not very specific, but you might hear them also in your everyday life, concentrated and dilute. But instead of those generic terms, when we're actually talking about solutions in the lab, we have some more specific terms. We have the term saturated, which means it contains as much solute as it can under the existing conditions. And this is going to be temperatures, and for gases, it'll be pressures. So you might have experienced a saturated solution if you've ever made a beverage like iced tea, lemonade, things like that. And you notice that you add more sugar, but instead of dissolving, it just sort of sinks to the bottom. If you have any sort of remaining undissolved solute, you know that the solution that you've made is already saturated. It holds as much as it possibly can. Unsaturated is just anything below that saturation point. So unsaturated means that you could add more and it would continue to dissolve. And when we draw those, we tend to look at sort of when they're dissolved in there, what do we still have any individual molecules that are clumped together? Because ultimately, when you see sugar at the bottom of a glass, that's what you're seeing. You're seeing clumps of the molecules together rather than them being spaced out individually, which is what dissolving does to something. So again, anytime you see stuff at the bottom, you know you've got a saturated solution and you can't hold any more. There's also another thing you can have, which is called supersaturated. Supersaturated solutions have more than the maximum amount. And the way that you're going to do that is by manipulating the conditions. The most common way to manipulate the conditions is by heating it and then slowly cooling it. So very often, hot liquids can dissolve more of the solute than they could at room temperature. And so if you heat them and then cool them slowly, they're actually supersaturated. They've got more than the normal. And I'll try to post some videos of supersaturated solutions because they're really cool looking and they can do this fascinating crystallization that you see in this image here. So what we then end up doing with this idea of saturation is looking at what we call the solubility, right? The solubility, which we can represent on a graph, is how many grams of the solute we can dissolve per some amount of water. In this graph, it's per 100 mils of water. The solubility typically changes with temperature. So in this case, we see that this graph has a positive slope, which means as you increase the temperature of the water, you can dissolve more of this particular chemical. So we can then ask some questions about this, and this is again still on page 4. The line itself represents a saturated solution, right? If you have that much, your solution will be saturated. If you have more than that, which is anything above this line, you'll have a supersaturated solution, and below the line is an unsaturated solution. So if I dissolve, say, for example, 50 grams, really at any temperature, I will have an unsaturated solution. That just means I could have dissolved more. Then we can ask questions about this, like at 20 degrees Celsius, a saturated solution contains how many grams in 100 grams of water? So I would go over to the 20 degrees, trace it up to the line, and then trace it over to the y-axis where I find that it would be 90. I can then answer the same question at 70 degrees. Again, I go over to 70 degrees on the x-axis, find the saturated line, and trace it over to the y-axis. And that looks like 135 grams. Next up, we can ask questions like what kind of solution is formed when we use 90 grams at 30 degrees. So now I want to see just where does this fall on the chart. So here's my 90 grams, here's my 30 degrees, and that's the line that it makes, or the dot, I should say, the data point. That data point falls in the unsaturated area of our graph. What kind of solution is formed when 20 grams is dissolved at 120 grams is dissolved at 40 degrees. So here's your 120 grams and 40 degrees. Lost my pointer. There it is. And that is above the line in the supersaturated area. So just by looking at the graph, we can see a lot of different things about how much dissolves under different conditions. So the next thing you'll eventually be doing is page 5, where you're looking at a solubility versus temperature curve for a bunch of solids. You can see many of these have a positive slope of one form or another. And you can see that this is just a whole bunch of different chemicals all put on the same graph. So it's kind of busy. There's a lot to read. But as you do the worksheet that goes with it, you'll see that it's going to ask about some specific chemical. And then you find that line and you can interpret that line. But I think it's just pretty interesting how many different chemicals can have such different solubilities, right? Most with positive slopes, but some with negative slopes, right? Some, as you heat it up, you can actually dissolve less of them. And that's going to typically also be true of gases, by the way, which is why hot water is bad for fish, because it holds less dissolved oxygen in it. So that should be everything you need for solutions, concentration, and solubility. Let me know if you have any questions.